Okay, so we're going to do section 5.6 to start today with, and that is finding the rational zeros. Remember, a zero is also called a solution to a polynomial equation. It's actually also called a root sometimes, and sometimes it's called an x-intercept. So we will look at the graphs in a little bit and see why they're called an x-intercept. So what we want to first do today is find the possible rational zeros. So that means all of the possible solutions you can have for a polynomial equation. You can't just have any answer. Okay? The answers or the solutions to a polynomial equation can only be very few things. And so the first thing we're going to do today is practice getting the possible rational zeros. Now, when I say zero, I'm not talking about the number zero. I'm talking about a solution. Okay? So the way we do that is P over Q. P over Q. You need to memorize that. P over Q. P is the factors of your constant term. Remember, the constant term is the term on the end that has no variable. And Q are the factors of the leading coefficient. So, this makes more sense when we have a polynomial to look at. So, the directions say find all possible rational zeros. So, we're not finding the solutions, but we're finding what they could possibly be. Okay, finding the possible rational zeros, which means the possible rational solutions. So here's my polynomial equation. X to the third plus 2x squared minus 11x plus 12. And to find the possible rational zeros, we're going to use P over Q. Now, P is the factors of your constant term, which is the term on the end if your exponents go in decreasing order. And Q are your factors of the leading coefficient. Now, what is Q in this problem? What is our leading coefficient in this problem? 1. Okay, so we're going to use 1. So for P, we got to consider the positive and the negative. So we're looking at 12. What numbers multiply to get 12?
6 and 2.
6 and 2, 3 and 4, and what else? What else multiplies to get 12?
1 and 12.
1 and 12. So I'm going to put them in order. 1, 2, 3, 4, 6, and 12. And I put the plus and minus because it could be a positive 12 and a negative in a positive 1, or it could be a negative 12 and a negative 1. Does that make sense? So those are all of my factors of 12. That's my P values. For Q, we want all of our factors of the leading coefficient. And y'all, the leading coefficient is 1. That makes life easy. So our only factors that multiply to get 1 is what? 1. So we say plus and minus 1. So to find the possible zeros, or possible solutions, we do P over Q. That means we take every single P and put it over every single Q and we simplify. Now, these are really easy because these are all going to be over 1. So you say plus and minus 1 over 1. 1 minus 3 over 1. Plus and minus 4 over 1. Plus and minus, what? 6 over 1. And plus and minus 12 over 1. So you just take all the P's and put them over all the Q's. And then you simplify. And everything divided by 1 is going to be itself, right? So plus and minus 1, minus 2, plus and minus 3, plus and minus 4, plus and minus 6, plus and minus 12. So the only solutions to this polynomial equation have to be positive 1 or negative 1, positive 2 or negative 2, positive 3, negative 3, positive 4, negative 4, positive 6, negative 6, or positive 12, negative 12. It can't be any other number. It couldn't be a negative 5, right? It can't be negative 100. It can only be one of these numbers. Isn't that cool? Math is so cool. We don't necessarily know what these solutions are. I can easily get it. But I know it can only be one of these 12 numbers. Right? 6 positive numbers or 6 negative numbers. So cool. So let's do it for a more difficult, challenging polynomial. I'll just say more challenging, not necessarily difficult. So this time we've got the function f of x equals 4x to the 4th power 9x minus 10. All right. So what's my constant term? Negative 10. So that's my p. So let's list all of my factors for p. Now what all will multiply to get 10? 5 and 2, and what else?
1 and 2.
So I'm going to put them in order. Plus and minus 1, plus and minus 2, plus and minus 5, and plus and minus 10. Nothing else multiplies to get 10, does it? Okay? So for q, you look at the leading coefficient. So what's the leading coefficient of this whole polynomial? 4. So what all multiplies to get 4? Yeah, so 1, 2, and 4. That's the only numbers that multiply to get 4, right? You don't have to repeat the 2. That's kind of redundant. So to get our possible rational solutions, we do p over q. And we put every p over every q, and then we simplify. Okay? So first I'm going to put all my p's over 1. So plus and minus 1 over 1, plus and minus 2 over 1, plus and minus 5 over 1, plus and minus 10 over 1. And I put all my p's over plus and minus 2. So that will get me plus and minus 1 over 2, plus and minus 2 over 2, plus and minus 5 over 2. Y'all see what I'm doing? And then plus and minus 10 over 2. And then last I put all of my p's over 4. So plus and minus 1 over 4, plus and minus 2 over 4, and plus and minus 5 over 4, and plus and minus 10 over 4. Now, y'all might be noticing that some of these are repeated, right? Because 2 over 2, for instance, equals what? 1. So my last step is to simplify all my fractions, and we'll notice that some of them are repeated. So if they're repeated, we just leave them out one time, okay? So these whole numbers will be the ones over 1. So plus and minus 1, plus and minus 2, plus and minus 5, plus and minus 10. And then plus and minus a half, we don't have that one yet. 2 over 2, we said that equals 1, so you don't have to say that one again. 5 over 2 is 2.5. Do we have that one yet? No, so leave that 5 over 2. 10 over 2 equals what, simplified? 5. Do we need it? We already got a 5, don't we? I don't know why I crossed that one out, sorry. We already got a 5. So 1/4, we don't have that one yet, so put it down there. 2 over 4 equals what? A half, and we already have that one, so we don't need it again. 5 over 4, that's 1.5. We don't have it yet, so put plus and minus 5 over 4. And 10 over 4 reduces to 5 over 2, doesn't it? And we already have a 5 over 2, so we don't need that one again. So my possible solutions for that polynomial are these numbers. Okay. So if you have equations, your homework, I think, says find all the possible rational zeros. Let me read the directions. It says list the possible rational zeros for the function using the rational zeros theorem. That's what we did. P over Q is the rational zeros theorem. Okay. So that's how you find out what will be a possible solution. So the next thing we're going to do in this lesson is actually find the real zeros. Yeah. So this is where the bulk of the lesson will be. Find all real zeros of f of x equals x to the third power minus 8x squared plus 11x plus 20. Now, if they wanted the possible ones, we would do P over Q, right? And get all those numbers. But they didn't want just the possible ones. They want the ones that actually were the solutions. All right? So I'm going to tell you a little shortcut how to get the first one. And then we're going to do synthetic division to get the rest of them. Okay? Like we did yesterday. So to get the first one, we're going to use our graphing calculators. So y'all get your graphing calculator turned back on. And I want you to go to y equals, it's on the top left corner right here. I know mine's hard to see because my projector is dim and I apologize. So you go to y, turn it on, go to y equals. And then you're gonna type in this polynomial. Okay? Now, to hit a third power after you hit the x, you're gonna hit the rooftop button. The rooftop button is over there underneath the little arrows.
So we're going to type in an X.
You're going to type, I've already cleared it out for you. All right. So you're going to type in the X. The X is right here beside the alpha button. There's a bunch of variables there. Can I see it? If you hit the variable button, it should be generated. So hit X rooftop 3. And then you can say minus. Now, y'all, for minus, you need to hit the blue minus, not the little negative at the bottom. You got to hit the blue minus over here. Minus 8x, and the square button is diagonal from the 7. So that one actually has a button. Plus 11x plus 20. And before you hit anything else, I want you to look up at my screen. I know it's hard to see, and make sure yours looks like me. X rooftop 3 minus 8x squared plus 11x plus 20. Uh-huh. X rooftop 3 minus 8x squared is right here. Plus 11x plus 20. So, does everybody have that keyed in? All right, then I want you to hit the graph button over here on the bottom right. Or, yeah, underneath the screen at the right. Graph button. And if your screen does not look like my screen, raise your hand. Does everybody have that polynomial graph? Now, this is not the entire graph. Huh?
It showed me the new there. It's sitting down to there.
Get another calculator. Is this 7? What number is this?
5.
One of these is not working out. I don't know what's going on. If you brought your own calculator.
I'll look more if I can remember. Something like this.
That's why teaching graphs is like the most stressful thing. Everybody's calculator does something different. Plus 11x plus 20. That's a good one. Okay. So, does everybody see this screen over here? Now, y'all look. Where you're crossing the x-axis at, those are your zeros. Those are also called the solutions. They're also called the roots. They're also called the x-intercepts. Okay? So, your zeros should be at everywhere you're crossing the x-axis. All right? This one is a pretty graph. Most graphs are not pretty with polynomials. And this don't even show you the whole thing, because see, like this polynomial starts down, then it comes up and makes a hump up there, then it goes down, then it comes back up. That should be a degree 30. Yeah, it's a degree 30. Okay? So, what you do is you pick one of your x values that you're crossing at. I'm just going to pick this one, -1. I'm pretty much sure that's crossing at -1. Y'all agree? So, come over here and you're going to use -1. And you're going to do synthetic division to get the other two. Now, since we can graph it, we can check it that way. Yes, but I want you to do it this way because they're not always going to be pretty on the graph. Check with do your graph, do your calculator to get 1, do your algebra to get the other 2. Okay? So we're going to use -1. Put your your coefficients in. 1, -8, 11, 20. Skip a line, draw a line. Bring down your 1. Bottom times corner, and you get -1. Then you add, get -9. Bottom times corner gets +9. Put it there. Then you add. Bottom times corner gets you -20. And you add and get 0. So I'm getting, go down a degree, x squared minus 9x plus 20. And that's factorable, is it not? Multiplies to get 20, adds to get -9. -9, 5, and -4. So that's x minus 5, x minus 4. Set those equal to 0. X equals 5. X equals 4. And don't forget that one we found on the calculator. X equals -1. These are all of my real zeros. And again, when we did our calculator, did my other two cross at 5 and 4? Yes. So use your calculator to get 1, synthetic to get the other 2. Synthetic and then factor. Okay? All right. Let's do another one. I want you to take your y equals. Your calculator. Clear everything. Y equals, and then hit clear. And it should get you a clean screen. Keep using it till it dies. It'll stay low battery for a long time. All right, next one. We're finding all the real zeros for f of x equals x to the third minus 4x squared minus 15x plus 18. So type that one into your y equals x rooftop 3 minus 4x squared. And then wait on me and then hit graph. Look up at mine. Make sure you have it typed just like me before you graph. I could have made a mistake myself. I have to double tap mine to get it to work. So that's
what about the little arrow key? Can you go down and look at the back?
You can zoom out, but I wouldn't do it because it messes up your view, and my little freshmen will freak out if their calculators don't do what they're supposed to do. They do. All right, I'm going to hit graph now and see if your polynomial graph looks like mine. Does it like it? Yeah. So obviously there's going to be like a hump right there, a vertex up here, and then a vertex down here. Right. We just don't see the whole thing. We could zoom out forever to find those, but we're not going to. So tell me an x intercept where I'm crossing at.
We keep finding the x. What can we find the y?
When it asks for something besides zeros. You type something right. I'm having little negatives. All right. Is everybody else got my polynomial graph? All right. Somebody tell me one of the x-intercepts there.
Looks like 3, 4.
3 is not an x-intercept.
That's the, never mind.
That's negative 3.
-3.
All right, you want to use negative 3?
Yeah.
Okay.
I seen the main one.
Yeah.
Main.
So I'm going to say 1, negative 4, negative 15, 18, and I'm going to do synthetic division. Aren't y'all good? Y'all are good at, aren't y'all glad you're good at that? Bring it down. 3 times negative 1 is negative 3. Then you add, get negative 7. Negative 3 times negative 7 is positive 21. Then you add and get a 6. And negative 3 times 6 is negative 18. No remainder. So x squared minus 7x plus 6. Is that factorable? Yeah, we're multiplying. Well, we're multiplying to get 6 and adding to get negative 7. What does that? Both negative, though, right? So that's x minus 6 times x minus 1. I'm going to set those equal to 0. So x minus 6 equals 0. X minus 1 equals 0. X equals 6. X equals positive 1. And I already said x equals negative 3 from my graph. And then look back at your graph and make sure I'm crossing the x-axis at those numbers. Yay.
How come these lines like they go straight down and then over one? Straight down over one. Why can't they go to the diagonal?
Talk about these? Because they're not a straight line. It's a polynomial graph. We're going to talk more about it tomorrow. But you can't see the whole graph. But what's happening is it starts down here at infinity, negative infinity, then it goes up, and then somewhere up here it makes a hump, and then comes back down, and then makes a hump, and then comes back up. So you're not seeing the whole graph. We're going to see the whole graphs tomorrow. Okay. We just need to know the x-intercepts anyway. Or at least one x-intercept. So all we got to find is one. I'm trying to decide which difficult problem I want to do first. I choose this one. What example letter are we at? E. G of x equals 2x to the 4th power minus 9x to the 3rd power plus 37x minus 30. All right, y'all pop that in your calculator. Clear it out. Go to y equals, hit clear. Make sure you use the big minus sign, not the little one. All right, now this one we put rooftop 4, don't we? It's a 4th degree polynomial.
We could grab 2, probably.
Don't do it. You don't want to do that. Yeah. Y'all make sure you copy it right. Make sure I copy it right. Because there's not an x squared. There's not an x squared. When I do what? Well, you'll have so many x-intercepts that you won't be able to tell which one you're looking at. Yeah, but I'm not dealing with that today. I'm only showing what I want you to know. Mm-hmm. But, I mean, when it's obvious like that, why make it difficult? All right, so I'm going to hit graph and see if y'all's graph looks like my graph. Okay. See how that has a little dip right there?
It goes below 1.
Yeah, so I can't really tell exactly what's going on right there because, I mean, these are little pixels are kind of hard to read at that point. But it does look like it's crossing the x-axis at 1, doesn't it? Does everybody pretty much agree with that? It looks like it's crossing the x-axis at positive 1. So let's use 1. Oops. So my coefficients. Okay. Now, y'all, I see I don't have an x squared. So what do I need to put in its place when I get to the x squared? A 0. So we got to hold that place. Hold the place of the x squared with a 0. Skip a line, draw a line. Bring down my 2. 1 times 2 is 2. Then I add and get negative 7. 1 times negative 7 is negative 7. Then I add and get negative 7 again. Right? 1 times negative 7 is negative 7. Negative 30. 1 times 30 is 30. And that gives me 0. Right? So this one, remember you drop a degree. So this one is 2x to the third minus 7x squared minus 7x plus 30. Now, guys, we can't factor it or do quadratic equation or anything until we get it down to a quadratic, which means it needs an x squared, right? So I'm still 1 degree too big. So what we're going to do once we're 1 degree too big is we want to go down to x squared. So go back to your graph and pick another x-intercept that you think we're exactly crossing.
3.
Well, you don't know. I can't see it on mine. How about negative 2? What about negative 2? Okay, let's use negative 2. So this time when we do negative 2, we're going to use our new polynomial.
So what happened with this one? Made a difference.
Do what?
Why is this one?
Because it's a 4th degree polynomial instead of a 3rd degree. It starts out with too many degrees. Too many exponents. So let's do this one with our new 3rd degree polynomial. 2, negative 7, negative 7. Skip a line, draw a line. Bring down my 2. 2 times negative 2 is negative 4. I add. I get negative 11. Negative 2 times negative 11 is a positive 22. And negative 7 plus 22 is 15. Right? And then negative 2 times 15 is negative 30. So this is 2x squared minus 11x plus 15. Now we could try to factor that, and I think it will work, but I'll have to do the long way. It does work. But I'm going to do quadratic formula just because I haven't done one with quadratic formula in today's lesson. And just to make sure we remember quadratic formula and how to work it, equals negative b plus or minus radical b squared minus 4ac divided by 2a. Yay. All right, so here we go. This is my a, this is my b, this is my c. So x equals negative 11 plus and minus the square root of negative 11 squared minus 4 times a is 2, c is 15, all divided by 2 times a is 2. So that's 11 plus or minus the square root of 121. 8 times 15 is what, y'all? 120. All divided by 4. So under the radical, what's 121 minus 120? No, it's just 1. So 11 plus and minus the square root of 1 over 4. What's the square root of 1, though?
1.
So 11 plus and minus 1 over 4. So then it's two problems. X equals 11 plus 1 over 4. And x equals 11 minus 1 over 4. What's 11 plus 1?
12.
What's 12 divided by 4?
3.
Y'all are right. It did cross at 3. 11 minus 1 is 10 over 4. Reduces to 5 over 2, which is 2.5. Did the other one look like it was kind of crossing close to 2.5? So it wants us to list all the zeros, so don't forget to put these in there too. X equals 1 and x equals negative 2. How many solutions did we have? 4.
No, how's that?
How is that?
Because it's not on the computer.
Yeah, there can be. Okay, there's 4.
We're going to zoom around.
Let me see.
Where's the zoom?
Hang on. Where'd my graph go? How many x-intercepts did we cross at? Right here is 1, 2, 3, 4. These are really close together. So there were 4. So something we're going to talk about in a little bit will be the fundamental theorem of algebra. Tells me however many my highest exponent is how many solutions I should get. Now, sometimes they're all real, like this one had all real solutions. Sometimes they have some imaginary solutions. So we're going to talk about that in a little bit. Stay tuned. Stay tuned. Okay, let's do one more. Those are really as long as they get, y'all, is when they start out with a high degree polynomial, like bigger than a cube. And then, so what you have to do is keep doing synthetic division until you get down to a quadratic. And after you get a quadratic, you can either factor it or you can do the formula. Now, if the leading term is a 1, I'd try to factor that baby, but not everything is factorable, unfortunately.
If the leading term is.
What?
You said, what you said, the leading term is.
If the leading term on your quadratic, once you get it all the way down to a quadratic, if it's a 1, try to factor it. Yeah, if not, I would just stick it in quadratic formula every time, unless you like to factor the long way. And I'd prefer not to factor the long way. That one could have been factored the long way, because what multiplies to get 30 and adds to get negative 11 would be a negative 5 and a negative 6. And you could have done the group in there. I just wanted y'all to see quadratic formula. All right, so that was example E. Let's do F. Let's do another big one. A big one. F of x equals 9x to the 4th power plus 3x to the 3rd power minus 30x squared plus 6x plus 12. So what did we do first, y'all? Yeah, clear out your y equals. Type it in. Oh, I forgot my x. You better put those x's in there. That's going to make yours look not like mine. Take a gander up at my screen and make sure yours looks typed in like mine when you get finished. Because if you don't, your graph won't look like mine. Negative 30x squared plus 6x plus 12. All right, now let's all hit graph together and see if our graphs look the same. Whoa. Those look like that crap. Okay. So, tell me an x-intercept that you think you can see.
-1.
No.
Maybe positive.
Let me zoom. Eh. Never mind. Let's guess. Well, that's -4, 5, 6, 7. -2, maybe? And a +1?
Yeah.
Let's try -2. What did I use earlier? I used -2 and +1. So let's try those. So 9, 3, -30, 6, and 12. Do synthetic. Skip a line, draw a line, bring down the 9.
18, -18.
Uh-huh.
-15.
Uh-huh.
+30.
Uh-huh.
0.
0.
-2. 0.
Mm-hmm. 6.
-5.
And that's remainder 0, right?
That makes you not have a
X term, right? Because it goes down a degree. So this is going to be 9x to the 3rd minus 15x squared. You can leave out you can put +0. All right, now let's go. We got to get to a quadratic though, so we got to do it one more time. And what do we say? +1 was close to our graph. Let's see if that is one of them. So here's our new polynomial. So we're going to use 9, -15, 0, and 6. Skip a line, draw a line. Bring down my 9. That so rhymed. 1 times 9 is 9. Add, I get negative 6. 1 times negative 6 is negative 6. Add, I get negative 6. 1 times negative 6 is negative 6. Add those, and you get 0. So that's 9x squared minus 6x minus 6. So yeah, let's do the quadratic formula here.
X equals negative b plus or minus radical b squared minus 4ac divided by 2n.
Good job. All right, so x equals negative b is negative 6 plus and minus the square root of negative 6 squared minus 4 times a is 9, c is negative 6, all divided by 2 times a is 9.
So x equals 6 plus or minus.
Square root of 36. What's 36 times 6? 36 times 6. 216. And that's going to be a positive 216 over 18. 36 plus 216. 252. I'm just adding under the radical. Is that a perfect square? No, it's not.
How do you know it's a perfect square?
Because you can type it in your calculator and it doesn't get you a whole number for one. Another two, I have my perfect square memorized. Up to like 20. So I got to find the largest number that goes into 252 that is a square. 16 don't go. 4 goes, I know for sure. 252 divided by 4. Oh, see if 36 goes into it, don't it? Because I just used 36 to do it. Be 36 times 7. So radical 252 equals radical 36 times 7. So that's 6 radical 7. Y'all agree?
So like, where do you know where to start?
We did that back in like chapter 2. I know you need to know the largest square that goes into something. And I tried 4. 4 went, and it was 4 times 63. Well, I know 9 goes into 63, so I just put those two together. And just tried stuff. All right, so that's x equals 6 plus and minus 6 radical 7 divided by 18. So I divide them both by 18. That gets me 1 plus and minus 1 radical 7 divided by 3. The 6 over 18 reduces to 1/3, and 6 over 18 reduces to 1/3. So these are two answers right here. I can't simplify anymore because I don't know what radical 7 is. So there's 2 of my answers. My other 2 are the 2 I use for division. So x equals 1 and x equals negative 2. So those are my 4 solutions right there. So sometimes we'll get an ugly solution like these. These would be the 2 over there, but we couldn't tell where they were on the graph. Does that make sense? So if you want to, you can type those in and get the decimal and see if it's close to that. So that would be, the positive 1 would be one of these, and the other 2 would be these 2 right here on the other side of the y-axis. So we like it when those whole numbers cross, but that's not always the case. All right. Okay, so for this section, it's only asking for the real zeros. What kind of numbers are not real? Imaginaries. So if you get an imaginary solution, guess what? You don't need it. Throw it out. Okay? So let's see an example of that real quick. And that'll be our last one. We'll stop there for today. We'll do the next section tomorrow. I've beat y'all to death today. Enough. All right, so let's graph them. Go to y equals hit clear. 2x to the 4th. Minus x to the 3rd. Minus 7x. Plus 4x. Minus 4. And hit graph. Boom. Boom. Does it like that?
You only get 2 points. Is that 7x squared or 7x?
Oh, that should be 7x squared. So fix that, because I probably didn't have that right. This is not what it's, yeah, it's supposed to be 7x squared. I apologize. I knew mine didn't look like it was supposed to. It's supposed to look a little different, but it's not supposed to look that different. And then you just got to type over it, plus 4x minus 4. Sorry, y'all fix the square on that 7x. That's better. Okay. You see how this one does the little, I was going to call them humps, and I was thinking of a better word. So, yeah. So, you see how that has a little dip right there, and then it comes back up or whatever? Okay? That would be like an imaginary solution. So, we're only crossing the x-axis at these 2 points right here. Y'all see that? Because this one's going to have imaginary solutions. Because according to the fundamental theorem of algebra, this is a degree 4 polynomial. I should have 4 solutions total, right? Only 2 of them are crossing the x-axis, so that means 2 of them are imaginary. Does that make sense? So what we're going to do is we're going to find the real ones, which looks like -2, +2. So I'm going to start with -2. Divide synthetically. I like saying that because it makes you feel smart. Divide synthetically. -2 times 2 is -4. Add and get -5. -2 times -5 is +10. Add and get 3. -2 times 3 is -6. You add and get -2. -2 times -2 is +4. Add and get 0. So that one's 2x to the third. I go down 1 degree. Minus 5x squared plus 3x minus 2. And our other one was at where? +2, I believe. 2x, oops, sorry, 2, -5, 3, -2. Bring down the 2, multiply. 2 times 2 is 4. There's -1, that's -2. Oops, yeah, that's right, -2, that's 1. That's 0. 2x squared minus x minus 1. All right, let's do quadratic again. That should be a +1, shouldn't it? Sorry. So x equals -b plus or minus square root of b squared minus 4c divided by 2a. So -1 plus and minus the square root of -1 squared minus 4 times 2 times 1 divided by 2 times 2. So that makes +1 plus and minus the square root of 1 minus 8. Y'all, what is 1 minus 8? What do we have when we take the square root of a negative? An imaginary. So that's 1 plus and minus I radical 7. I didn't want complex solutions. I didn't want all solutions. I only wanted real solutions, right? So that's technically a solution if it's asking for all solutions, but it's only asking us for real solutions. So that is not it. So my only two, and that's actually 2 because I had a plus and a minus. So my 2 reals are just x equals -2 and x equals +2. Boom, boom. How are we going to get good at this, y'all? Practice, practice, practice. So, unfortunately, y'all are not taking my calculators home with you. So, that means you need to work as best as you can, as quick as you can, and get as much as you can done. So, if I were you on your practice, I would leave the P over Q stuff until later. You can do that all at home without that. So, page 374. You need to do 3 through 6. Do these at home. And get as much of the rest of it you can done. Y'all are going to need access to your own graphing calculators for this class. So, I told y'all that before. Just out coming before we really need it. So save 3 through 6, the P over Q stuff till you get home. And y'all real quickly try to get as much of the other stuff done as you can. But it's just popping in and getting the graph and seeing your x-intercepts and doing synthetic division. It's not bad. What? There's my folder. La, 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 la. Chapter 4. Factor. And then systems of equations.